Well, good evening, AP Physics students. Hope you're ready for another physics problem with Mr. Kirsten tonight. But before we start today's problem, let's make sure we're properly hydrated and have a little green tea here along with our problem. Ooh. Oh my gosh, my tea is hot. Ooh, how did it get so hot? Man, I must have put it in the microwave for too long. Man, I wonder how many are microwaves part of the electromagnetic spectrum? Wow, I'll bet you my microwave contains photons. And the energy and photons in my microwave is what makes my Mandarin Orange Celestial Seasoning caffeine-free herbal tea taste so delicious. I wonder how many photons my microwave puts out each second. Wouldn't that make a good physics problem? I think it would. Let's check it out. So let's say I wanted to know, like problem 67 does, how many photons my 760 watt microwave puts out, assuming that the photons have a wavelength of 12.2 centimeters. All right. Now you might be thinking, how would one determine what the wavelength of a microwave oven is? And as it turns out, there's an experiment you can do at home with your microwave to determine what the wavelength of your microwave is. And all you will need is a ruler and a large piece of chocolate. Now, we don't have time to go into how you would do it right here, but I am going to put a link in the video description. And if you want to know how to find the wavelength of your microwave at home using a ruler and a piece of chocolate, watch that video. But anyway, let's get back to the problem at hand here. Well, I'll tell you what, before we tackle the problem of how many photons in 760 watts, how about we calculate the energy of just one microwave photon? So we remember that the energy of a photon is equal to Planck's constant times the frequency. Now, we are not given the frequency of this photon here, but we remember that the speed of any wave is equal to its frequency times its wavelength. And therefore, the frequency of any part of the electromagnetic spectrum is equal to c over lambda. So if we take this and plug this in here, we find that the energy of a photon is hc over lambda. And if we plug in these values for the photon, our microwave photon, we would get the following. Okay, we got Planck's constant, we've got the speed of light, and we've got our wavelength of our microwave. Don't forget to put that into meters. And we would find, better move our tea here. Oh, that's still really hot. Oop. And we're going to calculate some energy here. And we find that if we calculate this, got to move this a little bit here. We find that our energy of one photon, so the energy of just one photon is equal to 1.63 times 10 to the minus 24th joules. Now that's a lot of energy, but that's, just the energy of one photon. So if we wanted to figure out the total number of photons produced in 1 second, we would have to take the total number of watts or joules per second, all right, divided by the energy in one photon. So that would be the 1.63 times 10 to the minus 24th joules, right? And joules would cancel out here, and we would get N for our number of photons to be 4.66 times 10 to the 26th photons per second, which is a lot of photons. But then again, to get such delicious tea so piping hot, it would take a lot of energy and a lot of photons. All right, nice work, physics students, in calculating the number of photons in a microwave. Again, check out the chocolate bar ruler video in the link below that will tell you how to calculate the wavelength of your microwave and even calculate the speed of light using a chocolate bar. And then for your information about science that you just need to know, I would like to point out to you 20 things that you may not know about hair. Did you know that fur and hair are essentially the same thing, constructed of identical protein building blocks called keratin? Did you know that, let's see, more prehistoric highlights, some Neanderthals were redheads. A 2007 study at Harvard University and Germany's Max Planck's Society found a red-haired coding variant of hair color genes in 43,000 and 50,000-year-old Neanderthal remains. It says here that amongst the Neanderthals, gingers were likely joined by blondes and brunettes. The researchers note that, like modern-day humans, Neanderthals had variety in their hair. So as long as there's been human beings, and even before human beings with Neanderthals, there were redheads. So lots of interesting information about science all around us. Nice work with today's video. We will see you in class tomorrow.